Okay, hello everybody, and welcome to today's event on the networking channel. We'll be learning about a software-defined networking experience from the Asia Pacific region. It's going to be organized as a panel, and it's going to be led by three world-renowned researchers in the field of software-defined networking. We have Bruce Davie, who is Chief Technical Officer of VMware's Asia Pacific region. We have Motonori Shindo, a distinguished engineer and technology evangelist who is currently serving as Chief Technologist at VMware. And we have Kentaro Ebisawa, who is a principal researcher for Toyota Motor Corporation. Before we start, we also want to mention that the networking channel is a series of talks that happens every 2 weeks. And 2 weeks from now, we will have a talk on transforming challenges of internet governance, where we will be joined by Vint Cerf, Robin Mansell, Miriam Marzuki, and Jan Art Schult. A lot of us know how the internet works, but sometimes we don't think about how the internet really impacts everything from global politics to every aspect of our social and economic lives. And this panel will discuss still unresolved issues and highly sensitive challenges and how these transformations unfold to impact everything from how nations work to international relations and much more. So it should be extremely interesting to hear about that. But with that, we will start the panel for today. We would like to invite you to interact with our panelists. All our events are interactive. You can ask questions on the Zoom using the Q&A feature at the bottom of your screen. You can also enable closed captions if that's helpful for you to see what is being said transcribed on the text on your screen. And I will now turn things over to Bruce, who will be taking things from here.
All right, thanks Matt. I'll just get my slides up here. Oh, sorry, just one moment. Okay, so we do have three speakers today, myself, Shindo-san, and Ebiken. I'm going to kick things off with kind of an overview of my experience dealing with SDN and its commercial adoption in the Asia Pacific region. As Matt said, I used to be the CTO for Asia Pacific for VMware, and I still live in the APJ region. So I'm just going to start with a quick sort of overview of some of the things that we experienced trying to get SDN to take off in this region. And actually the real in-depth stuff is going to come from my two colleagues from Japan, Ebiken and Shindo. They were both involved in the translation of the SDN book that Larry Peterson and I wrote. And so you can see the Japanese edition here. And in producing this book, they not only did the translation, but also created specific Japanese content to make the Japanese publishers happy. So they've got deep knowledge of SDN in Japan. But I'm going to start off not only with the Asia Pacific overview, but also just a few things about the commercial adoption of SDN that maybe would not be completely obvious to people in this community. Now, first of all, get us all on the same page about what SDN is, because there's actually a lot of different definitions of it. I figure I'll be pretty safe if I just start with a definition from Nick McEwen, which is that a software-defined network is a network in which the control plane is physically separated from the forwarding plane, and that a single control plane controls several forwarding devices. Now, that's maybe not the most intuitive definition, given that it doesn't even mention software, but the key thing about this separation of the control plane from the forwarding plane is that it actually gives us the ability to dynamically change the behavior of routers by modifying the control plane. But it also does a lot of other things. And so that's what I want to talk about first, is like, what did we actually get out of SDN, particularly as we tried to bring it into the commercial world? A few key insights that I think maybe it took me a while to realize that this idea of having the control plane separated from the forwarding plane and then to centralize the control plane actually gave us the ability to create new abstractions. And it was Scott Schenker's talk in 2011 that maybe made this sort of ring true for me, was the idea that prior to SDN, it was very difficult to have any kind of network-wide abstractions because you were always configuring individual boxes. Whereas with SDN, we could now start to say things that had network-wide scope, simple things like these two entities, X and Y, should have a path between them and they should be able to communicate, and maybe two different entities, A and B, should not be able to communicate. But those are kind of network-wide abstractions as opposed to import these routes or run this OSPF process or something, which is what we used to do in configuring things at the box level. And a particularly important aspect of this was once we had network-wide abstractions was better security. And that really affected the way SDN took off commercially, as you'll see. Another big part of it was that I worked at Cisco for 16 years, and we fundamentally believed you could not do centralized control. And it was basically because we needed to import some ideas from the distributed systems community to make central control work. And this is one of those great kind of cross-pollination stories between two different research communities. And by bringing in ideas to have distributed systems that could provide logically centralized abstractions while being fault tolerant and scalable, that really was a key component of SDN. And once we had that, we could now put APIs on the whole network rather than just APIs on individual boxes. Again, at Cisco, we spent years trying to put APIs on boxes. We could never get it to take off, but it turned out that was the wrong abstraction. We needed APIs for networks. And once you have that, you can start having software systems provision networks rather than humans. And that's really important. If you think about any time you go to a cloud service, like spinning up a virtual private cloud at AWS, you don't have to go and configure individual devices. You simply say, I need a VPC, and then you specify that requirement and everything else happens underneath. So the software makes the configuration happen, and that's pretty important. And then finally, by separating out forwarding and control, we were able to create an environment where you could have different players getting into the space. And if you can have a bigger ecosystem of people or of companies creating these systems, then potentially you've got a lower barrier to innovation. And that's one of the things that has actually played out. This is another Nick McEwen slide that I borrowed. The idea that we're disaggregating networking. So instead of it being all bundled by the sort of the big integrated systems players, like the one I used to work for, instead we're breaking it up into different components where you have, some companies do merchant silicon, others package those into switching systems, others create network operating systems, and others create applications. And with this disaggregation, you have the potential for greater innovation. Some of that played out the way we expected. Some of it played out a bit differently. And here's a few quick thoughts on how the commercial adoption went. Now, both Shindo and myself worked for this company called Nicira. He started in 2011. I started in the beginning of 2012. And in February 2012, Nicira came out of stealth. That is, we started telling the world what we were doing, and it was reported in the trade press. And we had this thing called the Network Virtualization Platform, and a handful of big customers, including NTT, the big Japanese telco, who were one of the early adopters of network virtualization. And so I actually got to meet with Japanese customers and with Shindo himself in early 2012 as we started going to talk to these Japanese customers. But we had customers globally as well. Not very many in those early days, I should add. The idea was that network virtualization was perhaps going to do for networking what VMware did for servers. Well, funnily enough, 6 months after this announcement, VMware acquired Nicira, and that's where network virtualization got a huge injection of energy, people, sales forces, et cetera, to drive the adoption of network virtualization. So probably most of you know what a virtual machine does, but there's a really important analogy between virtual machines and virtual networks. And the key thing is that a virtual machine is a complete, faithful reproduction of every aspect of a physical machine. And it's done so thoroughly that you can take an operating system, drop it into a virtual machine, and it runs exactly as if it was running on top of physical hardware. And then you can pick up that virtual machine, which is just a piece of software, and move it to a completely different piece of hardware without even stopping it. And that's a kind of amazing thing that was enabled by the compute virtualization that made VMware a sort of household name. So the idea we had at Nicira was to do something very similar, but do it for networking. And so this really was a much bigger thing than just, say, VLANs or VPNs. It was virtualizing all of networking. And networking has a lot of moving parts from layer 2 through layer 7, load balancing, firewalling, all of those things had to be virtualized. And so this was our vision, which I guess eventually we got fairly close to implementing, which was that every aspect of networking could be implemented in software in a way that was decoupled from the underlying hardware. And our insertion point for this was to be able to create virtual networks that interconnected virtual machines. So now you could have virtual machines that could move around onto different hardware, connected by virtual networks that could also move around onto different hardware. And the only thing you needed to have sitting underneath all of this was some kind of generic packet transport. Well, so one of the big things that this enabled was that we could now create networks using an API. And you could speak to this API, or even more importantly, another piece of software could speak to the API and say, create a network with the following characteristics. And then the network virtualization system would receive that API request and then go and do a bunch of calculation and push out instructions to implement all the necessary forwarding state to create this virtual network. And it could do it in a way that was independent of underlying hardware, just putting the right forwarding instructions in the right place, and you could pick up virtual machines and move them, and all the networking would move with them. And so the first use case we had for network virtualization was automation. The idea that if you had a cloud automation system, it could not only spin up virtual machines, but it could also spin up networks to connect them. It could do things like NAT, and over time we added things like firewalling and load balancing, all the things that you needed to create a proper virtual network, and it could all be done through a cloud automation system. So our early customers were all focused on automation. But that turned out to be quite a difficult thing to get customers to adopt. The thing that really caused network virtualization to take off was realizing that it changed the playing field for security. And so we had started to appreciate around 2012, 2013, how badly broken the perimeter model of security was. And the idea that if you could get through the perimeter, you then had free reign to move around between different systems within a network. This was a huge problem. And a sort of canonical example of how people were building networks in 2012 was you'd have a small number of physical firewalls. You'd have to force traffic to pass through those firewalls, and you'd end up with lots of machines sitting on the same segment, all able to talk to each other, so that if somebody could, say, break into a system from HR, they could then move laterally into a system that was owned by finance. When there was no reason for those systems to be connected, it was just way too hard to provision networks to keep them separate. And so with virtual networks, we could start by putting each of these departments, say, on a different network, and then put very precise firewalling rules that said exactly how those machines could communicate to prevent the lateral movement of attacks. And that was really the big use case that got network virtualization off the ground. The next big use case came a few years later, and that was software-defined WAN. And this was one that Shindo had more exposure to than me. But one day, one of my colleagues at Nicira came to me and said he was going to go and work for Viptela. And he explained to me roughly what they were doing. And it was very much taking the ideas that we built at Nicira, but instead of applying them to virtual machines, it was applying them to branch offices. And as soon as I heard this, I thought that's going to be fantastic, because it's applying this idea of network-wide abstractions and centralized control to the wide area, just as we had failed to do when we created MPLS 10 years earlier, because we didn't believe in centralized control. So I had a sense this was going to be big, and indeed it was. Okay, that's all generic across the entire globe, how SDN took off commercially, really 3 big use cases. What about APJ specifically? So as I said, I was the CTO for APJ for a number of years for VMware. And so I saw how things played out across the region. And there's There we go. There's no single answer for APJ because it's an incredibly diverse region. By the way, we use the term APJ, Asia Pacific and Japan, even though really it should be just called Asia Pacific, I guess. Anyway, there's just an enormous diversity of different economies, different cultures, different languages across the region. And so every country is a little bit different. One of the things you see, for example, is there's some real small but quickly developing economies that are displaying this phenomenon known as leapfrogging. So, for example, we had quite good success in Myanmar with network virtualization because digital banks were starting up there without ever having had a physical bank. So they just like leapfrogged, just the same way you'll hear about, in many countries that are developing quickly, they never had a good physical phone system or landline phone system. They go directly to cellular. So same thing happened with network virtualization. It took off quickly in some of those developing economies. Things like price sensitivity can be completely different in some countries. So for example, India, the telcos were aggressively going after new customers. I just looked up the results from Reliance Jio. They have an average revenue per user of about $2. Now, I don't know how you run a telco with $2 per user, but they do. They're big, they're growing rapidly, but it means they're very sensitive to price. And that means if you come in with a product that says, well, we're going to, save you some amount of money, but it's going to cost you this amount of money to deploy the software in the first place. Or even if you say, we're just going to make your systems more efficient and it's going to cost you this much money for the software, can be a difficult sell. Particularly, if you say, well, we can make you more efficient, often the answer will be, actually, we don't care. We're just going to throw more people at it. Security, however, matters everywhere. And so that did become the kind of uniform use case all across the region. We could always go in and have a useful discussion about how we could make security better because there was nobody who didn't care about improving their security. We had, for example, very good success with financial institutions all across the region. ANZ is its own sort of interesting part of the region. Australia and New Zealand, very notoriously quick to pick up new technology. Things like the video cassette recorder back in the 80s, the internet in the 90s, both took off very quickly in Australia and New Zealand. Pretty much the same story with SDN. We had good traction there. Not uniformly good, but we did certainly have a lot of adoption there. Again, in many respects, quite similar to what happened in other developed economies. The cost of the WAN is a kind of special thing across the Asia Pacific region. Again, enormous variation between countries, but generally speaking, WAN costs can be very high because of poor connectivity, because of remoteness of communities. And so that can often be a big factor. If you can find a way to cut into that cost, SD-WAN gets a good opportunity to be inserted. And then maybe just one thing I'll say about Japan before I hand off to the real experts on that is I'd say I really enjoyed working with Japanese customers because they really liked going deep into the technology. Sometimes you would wonder why they needed to go quite so deep into the technology, but they had a very hands-on desire to understand exactly what was going on before they would adopt something. And I think there's sort of a cultural tendency to be fairly conservative before taking on a new technology. And so a really strong desire to understand it very well, which means, playing with it a lot in the lab, getting really good experience. And that's one reason I got to spend as much time in Japan as I did, was to go and meet those customers as they were digging in to get a deep understanding of the technology before deploying it. But anyway, that's kind of just a very high level overview of some of the things we saw going on across the region. But I think we can get some more granular and in-depth insights from the guys in Japan. And so with that, I'll hand over to Shindo to take the next piece of the presentation.
Thank you, Bruce. Let me share my screen. Do you see my screen okay?
Very good.
Okay. Hi, everybody. Thanks for joining. I'm Shindo at VMware. Today, we're going to talk about SD-N and SD-WAN use cases, often seen in Japan, and why they got traction in Japan. Okay, a little bit about myself. As you can see, I've worked at a number of networking companies, but most notably, as Bruce mentioned, I worked at Nisira, later acquired by VMware, and also Biptela, SD-WAN startup, and again, acquired by Cisco. Please feel free to reach out to me anytime, follow me anytime, whatever. And let's go into the main topic. As Bruce mentioned, SDN had several promises or anticipated use cases, as you can see here. And one big dream that we had when we were at Nisira was to commoditize the network hardware, because SDN will allow us to run almost all networking feature at the edge, and the data center networking will become much simpler. That will leading to a commoditizing the network hardware. That was what we believed, but in reality, it didn't quite happen, or at least in the way that we anticipated. Couple of reasons, maybe, but I think maybe because Cisco was too strong in that space, and also they were clever or smart, because they never disaggregate their hardware at all, unlike IBM did for their computers. The second use case we came up with was to getting around the VLAN limitation, which is 4,000 networks. But this use case didn't get the traction by many customers, because VLAN was probably good enough for most customers, even for large enterprises. VLAN was probably good enough, sufficient. Only those who really need more networks than VLAN can handle. I think there are only service providers or telcos. So not so many customers adopted this use case. The next, automation. Again, Bruce mentioned, this is a very legitimate use case of SDN, because controller can work as an entry point for API for the entire network provisioning. But in Japan, in particular, people didn't adopted this use case that much, because most of the Japanese customers are relying on system integrators. They will not configure their network by themselves. System integrators will do it. So customers don't care much about how the network is provisioned, either by automation or manual labor. Last but certainly not the least, security, I think, became the first most widely adopted use case for SDN. And when it comes to security on SDN, that problem means microsegmentation. And this was so widely adopted because everybody cares, security. Security matters for everybody. Almost no exception, right? But there was another reason why this use case, microsegmentation, was so widely adopted in Japan. Was this so-called internet separation. This was the architecture that the Japanese government recommended and almost enforced to all government offices. First, they split their network into two areas. One is internal systems area where they're going to run very important application like social tax or healthcare, and another area, internet isolated area, where they can run browser, email, or other internet related applications, typically on a VDI instances, a virtual desktop infrastructure, basically a virtual machine, and split those two areas completely, in isolated manner. Only traffic between those areas are screen sharing, so remote desktop thing. By deploying this kind of architecture, even if one of these VDI instances got affected, let me use the laser pointer. One of these VDI got affected by a malware. It will not go into this internal systems area, so people can secure this area. But still, they want to protect this internet isolated area. So that is exactly where microsegmentation comes into play. Because, VDI will typically run on a single network segment, and almost there is no traffic between VDI instances. It's easy to protect with microsegmentation. Like this firewall policy, traffic from VDI destined to VDI, use my pointer again, it's going to be dropped. That's it. This is all you have to do. Then all traffic between a VDI instances will be dropped, including malware traffic. This will prevent from the malware traffic, going laterally. And also, one more good news is, even if you want to add one or more VDI instances to the network, you don't need to do anything on this file policy. Still, this file policy will protect the newly added VDI instances. So it's very manageable and scalable solution. With this, that is the reason why many people in Japan adopted this VDI along with microsegmentation. Okay, let's move on to the second topic, SD-WAN. Here I listed a number of SD-WAN use cases, but let me map some more specific use cases and features that SD-WAN has, as you can see here. And please remember that not necessarily all of these use cases apply to a certain country like Japan. Okay, let's take a few examples. First, bandwidth aggregation. Bandwidth aggregation in SD-WAN usually means the bundling MPLS circuit and internet circuit to remediate the potential intermittent performance degradation in internet circuit. However, the quality of the internet in Japan is so high and cheap. For example, I'm currently connecting to Zoom for this conference. The circuit is 2 gig BPS broadband circuit, which costs me about $15 per month. Not 50, $15. And of course, 2 gig BPS is a theoretical upper limit. But I constantly get 400 or 500 megabps all the time, very stable. Only $15. So it doesn't really make sense to bundle internet circuit with another type of circuit like MPLS. It doesn't make sense that much in Japan. So, okay, let's take another example, MPLS replacement, because MPLS circuit is very expensive in other countries, but not in Japan. You can get MPLS a VPN service at $100 per month per site. Very cheap. MPR replacement, not so attractive in Japan. Okay, let's take another example, zero-touch provisioning. One of the sexiest SDN, SD-WAN use case, I believe. But as I mentioned earlier, most of the Japanese customers are relying on system integrator to provision that network. They don't even touch the network. So what they wanted to have was not the zero-touch provisioning, or sometimes referred to as ZTP. What they wanted was SCP, someone else's provisioning. Well, just kidding, but well, zero-touch provisioning didn't resonate with Japanese customers. Another example, template-based config. That will significantly reduce the amount of configuration that needs to be done on the edge devices, which can be hundreds of thousands. But again, same reason for ZTP, and customer don't configure the network, so they don't care how complex it is. Doesn't resonate. However, as I mentioned, internet circuit is very stable and cheap. So it does make sense to use internet circuit for a business use case. So internet breakout use case really shines in Japan. Well, let me explain what internet breakout is briefly. Suppose there's one user sitting in a branch office trying to connect, trying to use Office 365. Then the traffic will usually go like this. First, all traffic, a backhaul to headquarters and data center, and going into the internet, and eventually getting Office 365. But if the internet circuit is very cheap and stable, then why not having another internet circuit directly to the branch office and identify the traffic, and if it was an Office 365, for example, then steer the traffic directly over the internet. That is what internet breakout is. And this use case is very attractive in Japan. It may sound like a very simple, trivial use case, but in reality, it can be tricky. Let me explain. In order to tell if the packet was really Office 365 traffic, you need to see at least the first couple of packets, 3, 4 packets, to tell if the traffic is really actually in Office 365. So before that, the traffic will go through like this. It will backhaul to a data center and going out to the internet through a NAT. But once the edge router identifies the traffic is really an Office 365 traffic, then it will internet breakout like this. But again, it will incur a NAT process. So from the Office 365 perspective, first starting to see packets coming in from a data center, but all of a sudden it will be coming from another location with different IP address and different source port number. That will confuse Office 365, and most likely the connection will be dropped. There are a lot of ways to get around these problems. I'm not going into detail in today's talk due to the time constraint. Each SD-WAN vendor has own unique mechanism to get around this problem. But point is, internet circuit, internet breakout can be tricky. Okay, let me recap about what I just talked about today. SDN has solved many problems, but not all. And among those use cases, microsegmentation was the most attractive use case, most widely adopted use case for SDN. And SD-WAN, the similar situation there. a bunch of potential use cases. But what really resonated with the Japanese customer was the internet breakout, because the internet circuit in Japan is very cheap and stable. And I talked about a couple of use cases of SDN and SD-WAN, but they are not the exhaustive list of use cases. There will be more new use cases around SDN and SD-WAN over time. Well, good example would be network telemetry. That's a very attractive future use case of SDN, I think. So let's keep our eye on those new use cases. And that's all. Thank you. So let me hand it over to the next presenter, Ebisawa, Kentaro Ebisawa. We call him Ebi-Ken. So please, I'll take it away.
Okay, thank you for the introduction. I'm Kentaro Ebisawa. So actually, for the past 20 years, I used to be working mostly for the US-based startups and in the area of SDN and like building switches and network OS, etc. But I happened to work with Toyota like 5 or 6 years ago. And I think many people, I hope many people knows Toyota, which is the automotive vendor. And I also think that many people would think why Toyota would be interested in network technology, even for like SDN and those emerging technologies. And I think Bruce and Shindo-san has covered well enough for the general SDN technology. So I would like to share another use case, which I work on, which is demanding for the new technology in the networking space. And after that, I would like to cover some P4 and SDN community in Japan and why it is so active in Japan. So even as of today, there are many services provided based on data collected from the connected cars, and even the data is increasing. It's not only the data from a single car is increasing, but the number of cars itself is also increasing rapidly as well. And obviously, more emerging connected services, which requires more data, is under development. And just give an example, like some application for disaster and hazard information support, we need to pick up data, not the sensor data, but also we have to have some visual data like photos and videos of the road to identify which place needs repair and feedback to the operators. And these kind of services, which are enabled by more data from the automotives, are under development. And I believe it's not only by Toyota, but also from other automotive vendors. But frankly speaking, it's impossible to predict services which would be widely demanded or widely adopted in the next 10 or 20 years. So Toyota is building a platform to make adding your service easier. And this requires storing data in many different formats and having it at the right place on the globe. So we need to move the data around and quickly and efficiently. So obviously, this requires some improvements in the networking technologies. And there are some unique characteristics of network traffic for connected cars, like because we collect data from automotives, the traffic would be more upload intensive. So these days, most of the network technology is focused in the web and streaming, because it is like 80–90% of the internet traffic. But for the connected cars and other IoT kind of services, the traffic we send to the cloud and data centers would be much more than the data we receive from the upstream. Also, we have the application would be more distributed and location aware, because we are moving and you don't want the map of United States or Europe when you are in Tokyo. So obviously data and the application you want to use would be very location aware. And based on the time of the day, the traffic characteristic would change dynamically. So even in a single car, many applications with different requirements would run in a single device. So there would be more demand for computing resource aware and dynamic traffic engineering than the era of the web and streaming. So one of the examples I am working on is that to solve this, the upload intensive traffic, like for download traffic, we have many technologies like direct server return to load balance to the servers in a scalable way. But for upload, the load balancer itself have to scale, and which would cost, which would be very expensive, as you know. So I am developing a new protocol and new algorithm to load balance the upload traffic very efficiently, which is pretty much custom use case as of today. I believe this kind of use case would be very popular because not only automotives, but there are many IoT and many new services, interactive services coming. But when we started this research, we have to kind of implement these kind of new protocols and way of handling traffic by ourselves and test it in a scalable way. So it was possible by disaggregation and programmable data plane using P4, because before that, we couldn't kind of change the way that switches would handle the traffic. So I think SDN and the disaggregation is very useful for implementing and testing the very use case specific features and protocols. And the other part is not developing custom devices, but for more of global and dynamic control. We definitely need something at the edge, because the interaction between the automotives and the application demands, some of the services would demand for low latency. And many data are really local. So we expect that edge computing would be something very crucial for our services. However, compared to the center, cloud, and data center, obviously edge has less resource we could consume, and there would be some congestion based on the time in the day. So in that case, we have to kind of redirect some load to the nearest edge, which has the resource available to process them. And to do this, we need more kind of way of dynamically controlling traffic, even in the mobile network, which would require some APIs in the mobile network, and like we do have in data center networks. So we need to utilize SDN technologies, including overlay and traffic engineering, to achieve these use cases. And that's something we already see, but we expect that something we do not see as of today, or something not obvious, would be happen in near future. Like we are building more cars, which doesn't look like similar to the car we drive today. And we are even building cities, which we could utilize the connected automotives and make a new service which would involve the other resource in the city you live. So we are kind of trying to utilize SDN technology when building a new city. Actually, this wooden city is already under construction in the west part of Tokyo. So that is why Toyota, the car manufacturer, is very keen on the network technology and trying to help the network technology to evolve even faster. And for that objective, I am also trying to grow community in Japan. And I stood up a P4 users group in Japan like 3 years ago. But before going into that, I would like to briefly go over the history of the internet technology community in Japan to give you a sense why this kind of technology community is very popular in Japan. So in Japan, like other part of the globe, the commercial internet service started around, I think, 1995 or 94 or something like that. And a few years after that, some guys who went to the NANOG also thought we do need some local community to foster technology and industry in Japan as well, and started a network operators group called JANOG, which stands for Japan Network Operators Group, in 1997. And it's like, I think, 25 years ago. So since then, we are having like 2-3 meetings every year, and it's lasting for 25 years. Before the COVID-19, obviously we had on-site meetings, and we had like 1,500 plus on-site attendees for this non-sponsored event. It's a users group event, which I think it's very, very rare to have this kind of event, just focusing on network technology. And even during the COVID-19, we had some online and some hybrid meetings as well. And the nodes, the local nodes, even local regional logs in Japan is growing. I pictured 3 of them, but I heard that there are 2 or 3 more just stood up in the past 3 months. And another example of the technology community in Japan is that Interrupt Tokyo. Interrupt Tokyo, as name suggests, started to interoperate networking devices and protocols and services. And I think for many Interrupt conference, it's already trade show, and rather than the interoperating testbed. But in Japan, we still have the Interrupt network during the conference called Shownet, and we interrupt the new protocols like SRv6 in this year of the event. So we in Japan have these kind of networking technology community as a background, and so it was pretty natural for me to think of standing up another community focused on data plane programmability. So I was around 2015 or 16, I was working on the Xpliant switch, which was very closed proprietary data plane programmable ASIC. And I thought we need to build some interest in Japan, so people would be able to utilize that kind of new technology. So I gave some talks around 2017 and 18, and also open sourced some P4 code, so people could realize that what would be possible using the data plane programming. And this one is example of the SRv6 and GTP translation, which was introduced in the hackathon of IETF. And finally, around 2010, we had People Workshop, and which had 100+ participants, which was quite surprising because obviously we did not think there would be many people interested in data plane programming. So we stood up the P4 users group, Japan P4 users group, on 2019 with vendors and system integrators, and also users and researchers. And we had first users meetup around October 2019, and there was many many talks from different perspectives, like communities, user academia research, and vendors and system integrators. And we had hands-ons, we had another meetings, even during the COVID-19. And we are still growing. Apart from the conference, we communicate on the Slack, and the member of the Slack is growing even every year. So a week after next, we would be having the fourth P4 users meetup, and we are going back to in-person conference. And so why is this P4 community is important is that, as I explained in the first half of my presentation, I believe that network is no more just about routing and switching. So we have to have engineer familiar not only for routing protocols, but also who is familiar with software development to move in innovation in networking area forward. And I believe that open community is a place where people with different backgrounds could meet and discuss even before being the offshore project and exchange ideas. And traveling out of Japan is getting back to normal. So I hope this, my presentation would success to share what we are doing in Japan, and hopefully we could meet someplace on the globe and expand this community and the interest for innovation. Thank you. And I would give back to Bruce.
Thanks very much, Eviken. That was great, and thanks Shindo as well. So we've got a few more minutes left for questions, and I don't think any of us have to drop off at the top of the hour. But one question that came through on chat from Jim Carosi was about this question about automation, and both Shindo and I mentioned that some of our customers would say, "Well, I don't need your automation. I'm just going to throw more people at the problem." In various different forms. And Jim asked, well, is there a case that the network is more reliable or predictable if you automate things? And that, in my experience, was absolutely the case we tried to make. And I think it can be difficult to quantify. I think that's the hard part. If people were always coming to us and saying, could you quantify the financial savings of using network virtualization? Because virtual machines were great. I could go from 10 servers to 1 server. It was really easy to see the cost savings. What am I going to save if I go to network virtualization? It was a much more subtle argument to say, well, your configurations will be more accurate. You'll make fewer errors. You'll be able to provision things in less time. All of that was a more subtle argument. And so it was one of the reasons why we did not have the easy path to market that I think compute virtualization had. And it's also why microsegmentation became the kind of killer use case, was because of the way you could say, do you care about security? And that would get you a discussion.
Could I ask a quick follow-up to that question, Bruce?
Sure.
So I get 100% what you were saying about security, and I wonder about sort of the reliability, robustness. If you sort of predict out into the future, things seem to only get more complicated. Do you think there'll be, I don't know, a crossover line where it'll become obvious that there are benefits to having sort of SDN controlled configuration management rather than throwing people at the problem? Or is that just too hard?
To me, it's been obvious for a long time, so I may not be the right person to answer that. But I think it's really obvious for people who are big enough that this is the right approach. So all of our early customers were big because eBay was one of our favorites. They had built a custom system to provision virtual machines and networks for their developers. And it was such a pain to get the network configuration right in a timely way that when we gave them a very early version of a product that could automate that, it was a no-brainer for them because they had such a large number of developers. But go to a smaller customer and they would say, oh, you know what, I just put VLANs everywhere and I don't have to change them very often, so it's fine. So it was just like the bigger and more sophisticated the customer, the easier it was to show them that this was the win. And so conversely, we could go into a small bank and say, are you concerned that you might be, subject to a hacking attack? The answer would always be yes. And then, we had sort of famous examples where within days of having the first discussion, the customer would say, oh, well, microsegmentation, it's such an easy thing to turn on. Why would I not do it? So that's but high level, yes, you're absolutely right. As things get more complicated, everybody should be automating.
Great, thanks. And
one thing, let me add one more perspective. Oh, may I? Or sorry to interrupt.
No, go ahead.
As I mentioned, the structure and the IT industry in Japan heavily significant reliance on a system integrator. There is no incentive for system integrator to introduce the automation because that's how they make money. If the network is automated, they will lose money basically. So that's the reason why the automation is not so getting well in Japan at this point.
Although I feel like there's something wrong with that, but it's the same in Australia too. Huge amount of outsourcing to system integrators. I was surprised. That's a huge difference between Australia and the US. And yeah, to me, it's like, but surely you would like to be able to make the customer's solution cost less for the customer. But it does seem like, well, no, I put this many people on it, I charge them this much, and everybody's happy. And that doesn't make great sense to me, because you'd think, well, a new system integrator could come in and undercut all of these bloated ones. But again, I guess in Japan, when was the last time a new system integrator appeared on the scene, I suppose?
Actually, I see many telco operators started working on automation. Of course, it's about the cost, but more than that, the users' demand for more dynamic service deployment and the service change of the service. For example, we automotive companies don't require traffic for all of the day. Most of the people wake up in the daytime and use the mobile network in the daytime. So that kind of, or maybe we only need some traffic when some outside event would happening, like live concert or something. So to do that, we can't ask SIers to reconfigure the network every time. And we do have to have automation to do the configuration changes in like seconds and minutes. So that's another reason even the Japanese operators start looking for automation in the network.
Yeah. I always think it's funny because, Toyota's famous for automating the manufacture of cars, right? And so it's not like Japan is allergic to automation. It's just that somehow the networking industry was allergic to automation. So it's that was always the thing I thought we should be talking about when we try to pitch automation, was like, well, don't you want to build networks that are as reliable as Toyota's cars? And so anyway. As another question came in about virtual machines, because I referred to them quite a bit in my talk, and the questions about whether we had, do we still need virtual machines is part of the question. And the answer is yes, people still need virtual machines. Partly it's because of, it's the way certain applications were built. They were designed to run on virtual machines. They do provide stronger resource guarantees than containers. But that said, a huge amount of what used to go into virtual machines now goes into containers. And, everything I said today about virtual machines pretty much can be applied to containers. So we still need a way to provide automated networking for containers. So if you look at what's happening with network virtualization today, most of the capabilities I've talked about for connecting virtual machines are today applied to containers. And so, for example, there's virtual networking solutions for Kubernetes where you automatically create the network as more pods are spun up, all that sort of thing. It's in many cases, the shift from virtual machines to containers was just a total smooth transition for virtual networking. And then there was also a question about why would you ever migrate a virtual machine? Lots of reasons. Doing hardware maintenance would be one. Getting more efficient resource usage is another. So Rackspace was an early customer of ours that apparently was able to reduce their server cost by about 10% just by more efficiently packing virtual machines into the physical machines that they had, and they needed virtual networking to be able to pull that off. So maybe they weren't moving virtual machines very often, but ideally you'd like to have virtual machines all packed on the same servers so that you can just go turn off the servers you're not using. So this ability to freely place virtual machines anywhere in the data center is actually quite important from a resource usage point of view. And again, it applies to the container world as well, but people don't do live migration of containers. They build their applications in such a way that you can just kill a container and start it somewhere else. But the idea of moving virtual machines was definitely important for resource efficiency. And that's all we have on the. Maybe just go for the benefit, if anybody hasn't been following the Q&A window, we did talk a bit about SDN for wireless. And so I gave an example of the Magma core project that I've been working on. there's a link there in the Q&A. That's actually an application of SDN principles to the mobile networking world. And Shindo also mentioned that there's starting to be some other SDN use in the telcos for network programmability. We had a question about security of SD-WAN, and Shindo, you might, yeah, I guess you did jump in there as well. So basically, how do you secure that connection between the controller and the edge? And it is some version of TLS typically. So it's not rocket science, but there's an interesting aspect to it, which is that you don't want to be manually provisioning all of those connections between the edge devices and the controller. And so this thing about zero-touch provisioning actually was an important aspect of SD-WAN. And it's probably why I initially became a quick convert to SD-WAN, was because the whole focus for MPLS was to drive down the provisioning cost of edge devices. And we did a pretty good job compared to what we started with, which was frame relay. But in the end, it was still quite a lot of per site provisioning. And as effectively, SD-WAN really drove that very close to zero provisioning cost per site. And so getting the security right is part of the provisioning. We absolutely ruled out the possibility of using encrypted tunnels back in the MPLS days because we didn't have a model for how to do the provisioning. And these days, getting encrypted tunnels between two sites is trivial because the controller figures it all out for you. There was one more question about VR and AR, and my answer is really, I'm sure that VR and AR will leverage SDN somehow, but I have no idea how that will play out. Jim.
Could I ask one last question then?
Yeah.
So Kentaro, I noticed that you, in the mobility discussion, you talked about handoff issues and mobility, but it was within a carrier. And I think that relates to a question I wanted to ask earlier about a multi-carrier. I mean, even in a SD-WAN, maybe people could comment, one of you could comment on carriers that need to interconnect when they're each doing SDN, whether you see any hope for end-to-end solutions or end-to-end solutions, at least in a limited number of cases among sort of large-scale players who, are skilled at what they're doing and might trust each other enough to partner.
So you're asking about the multi-operator interconnecting, right?
Right.
So far, I do not see that kind of move because many of the applications is like device to the center as of today. Maybe it's just because I only see the automotive use cases, but there's no kind of device to device going through mobile, because even the mobile network the delay is too much for the safety reasons, and most of the applications among the outside of the safety, which does not require safety, is not peer-to-peer. But what we are seeing that we definitely need to kind of have a technology to use multi-access, which is not multi-carrier. It could be multi-carrier operators, but also addition to 4G and 5G, we need to utilize the local Wi-Fi or any other access, because we do want to keep the cars connected even there is any trouble in the mobile. And also from the cost and speed perspective, because we foresee that data is growing, and there is a chance because many cars are moving to electric vehicles, and we do need some electric stations, and which we could put some Wi-Fi station there. So not multi-operators interconnecting, but we do see a need for using multi-operators for the access line for both backup and for the performance perspective.
Personally, I'm a bit skeptical about inter-domain, inter-operator thing, because looking at the past, I've never seen a success in any protocol that has a prefix like inter-domain, blah, blah, blah. I've never seen any success. Probably the only exception is BGP, but other than that, I've never seen a success, so I'm a bit skeptical.
Mm-hmm.
Yeah, I think I agree with Shindo on that one. I think it's so hard to get these interoperability things going across these different administrative boundaries. And there's a reason why I think it's going to be really hard to replace BGP, is just because it's the thing that we've now had working for so many years. And while you can hypothesize a better way of sharing information across autonomous boundaries, it's really hard to dislodge. So certainly when I think about inter-provider SDN, I tend to think they're going to do SDN internally and then export something that's more well established to go across the boundaries.
Great, thanks.
There's a couple of questions came up. I think they might be more for Ebiken. If you want to have a look over in the chat window or the Q&A window. I was just going to say something about load balancing while you're looking at them, which is that because I talked about it a bit in my talk, although I think the question might be related more to yours. But for me, the thing that was really cool to discover about load balancing is that most of us have a mental model of a load balancer as a place where you send traffic and then it gets spread out to a farm of machines that can answer the query or whatever behind it. But in fact, a lot of load balancing, you don't need to send the traffic to one place. The sources of the traffic could themselves spread it out and send it to a range of different servers to handle the query. So if you think about sort of going from one tier of an application to another tier of an application, then you would sometimes see load balancers in there. And that's actually a great opportunity for network virtualization, because you can simply don't send the traffic to a centralized load balancer, send it directly from the source to one of many different destinations. And so we implemented a distributed load balancer as part of our network virtualization platform. And it meant you got all the benefits from distributed firewalling, which is you didn't have to send the traffic to a centralized thing. So you could scale it up, you could automate it, you could move the policies as you move the workloads, all the good stuff. We could do it for load balancing just as surely as we could do it for firewalling. I don't know if Ebiken, do you want to comment on the questions that have come up?
Yep. So the question was that what's the difference between upload and the download heavy traffic for load balancing? And well, from the technology perspective, of course, if you have silicon, expensive silicon, you could handle the heavy traffic in bidirectional way, but one point is that it's not cost efficient because load balancer needs to do more than the router, and to do that scalable, we need more and more silicon power to keep the performance. So that's one reason, and I'm sorry that I cannot disclose more. I have my paper accepted, which it's still not public, so I hope I could talk more about that in a couple of months. And I would add another reason for why download heavy load balancing system are insufficient, because of there are many kind of applications sending traffic and many vehicles sending traffic. We want the data from a single vehicle to land on the same server inside the server farm. So obviously the source IP address would be one identification, but I think in the future we want the load balancer to look a bit more deeper. For example, like VID in the CAN data we sent. There are some IDs which is identifying the automotive device itself inside the data. So if load balancer could look into that, then that would help the server avoiding to redirect data and sort the data based on the vehicles. So those kind of load balancing enhancement should help for upload traffic, and would be very different from how the download heavy load balancing system would work. So hope that answers the question.
All right, I think maybe it's good time to wrap up. Matt or yeah, do you want to take it from here?
Yeah, sure. Yeah, so thank you, everybody. We can kind of wrap up now. Thank you for the great panel. We just want to remind everybody before you go that the conversation is going to continue on the Slack workspace. So if you had questions for the panelists you didn't get a chance to answer, or you just want to say hello and introduce yourself, you can feel free to find there. The link to the Slack is in the chat. We also want to remind you that in 2 weeks, we're going to have our next panel on the topic of transforming challenges of internet governance. It should be a really interesting event. All our events are free of charge and they're open to everybody. So please feel very welcome to join and attend and interact with the participants. We're very happy to have you participate. And with that, that concludes our panel for today. Thank you very much for joining and attending, and we hope to see you at our events in the future as well. Thank you.
Thanks, everyone. And yeah, thanks for fitting us into a funny time zone.
Worked out great. A lot of participants. That's wonderful. Thank you.
Fantastic.
Thank you very much.
Thank you.